So basically, first I will explain problem. We are given n, let's say, houses, and each one is connected with just one edge, such that there is a cost of it, and it's called, let's say, Li. It's going like S0, L1, so there is a Li. And also some of the, let's say, vertices has an extra one edge, such that with distance di. Okay, some of them, not all of them, like let's say this one and maybe this one. After this, we have also given some c. We can take some of the two vertices on the main line and connect them with this edge c, and we want to minimize the diameter of this graph. Now, if you look it's kind of some kind of array problem, yeah. So I said that how much point you got? You got this one, yeah. Actually, we can also get this one. How? Like brute force, just because we have to build this new line on the main line, not here, not like this. So we have to just choose some n square pair of the nodes, okay, and just build. After building, in how many time you can calculate the diameter? Basically, you can again choose all possible pairs and get their distance. Just select which you want to connect, then after for each n square, try all possible. How to calculate distance between two nodes? Distance between two nodes is xi. Just a minute, yeah, I forgot that. If you have a li in this given order, you are just summing up them to give some position in the line. Like here is 0, okay, and here is li, and here is L0, here L0 plus L1. So partial sum will give me how much distance from the 0th one. Okay.
Right.
Then what you can do, just when you select two nodes, the distance is what? If it's, I will call this partial sum as a xi, okay? Xi is equal to sum of the li. A equals smaller than, okay, j. Partial sum. Now for this, if it's until now xj, and here xy, what's the distance to them? Xj minus xi. In case of there is no edge. In case of if this vertex is using that special edge, let's say we fix it this, let's say A and B city, okay, and actually we don't need to check. If I choose the, let's say, C and D, I'm trying to find the diameter for all possible C and D, then it's this distance, like here D, C, yeah, minimum of the what? This one direct distance, or like my selected pair, so there is a absolute value of x d is going to xp. Why it's not like this? X, let me write bigger. Xp goes to d plus x a will go to xc plus what? C.
Where is C?
Big C is a given.
C.
Yeah. AB is my selected builded road. It can go directly like this in this order x. Like I choose it all possible pairs. So I'm trying to find distance between D to C when I build the edge between A and B. So you don't need axis because this is bigger than it's obvious. So this, or it's B is going to the D, like actually D is going to the B and A is going to C. So they are just jumping over this. Why it should go this one? I mean, it's bad to go this one because A is bigger than B. A, B is my.
Basically, when we're adding that
AB edge, yeah.
No, that C edge.
Yeah.
We just find all the shortest path between all the
and maximum of them. I think there is. I even submitted some brute force of it.
In n cube?
In fourth actually, because we have to try all possible pairs. This one.
Then
Actually, I took here B and A B B. So actually, this is the one condition, and this is directly B to A for selected IJ H. This will give you n power of 4, so you should get 23, which is a brute force. Now I have to, if we want to improve, or at most you can go n cube, like you can do like what? After, like, where is the page? After fixing that, let's say if you fix this one, and instead of n square, you want to make faster, maybe you can do what? You can just do the kind of, it's again same problem. There is a circle and there is some lines, so you have to just consider like what's the minimum distance for this one, and sets with set. I mean, you will implement a lot of things and you can improve to the n cube log n, which will give you one more subtask with 3 point, I don't know, 8 point actually. So it's 31. I believe you don't need that solution because it's implementation heavy. Like you just fix this AB. Now you have a graph. You want to find the maximum diameter between all in n log n. You can do this with set. Now we, instead of direct n cube solution, I will directly jump to the n square log, something like this. How to do this? Now it's different. In most of the actual diameter problems, okay, when they say that minimize something, minimize diameter, you basically what to do, you will just binary search the diameter. After binary searching the diameter, you want to build such a edge such that between all pairs distance, shortest distance is smaller or equal to d. When you binary search the d, you want to binary search d. So you send your check function. Check function is kind of building such an edge between two pairs such that between all pairs distance is smaller or equal to d. Some kind of diameter trick, let's say. Like I see 2-3 problems in Olympus with same idea. You are just diameter problems. You can sometimes do the binary search and do the operation. Now how to check that? For checking, there are actually two solutions. First solution will using different trick. Second is using different trick. Second can be improved to the, like this one is solution n square log of the maximum answer. So answer, you are just binary searching the answer. 71 I think points. And this one is also same complexity at the beginning, but you can improve this to n log n log ans. So let's start with first solution. I mean, it cannot be improved. You can get at most 71, but this is the some, how to say, known trick of the mountain distance. I will actually show. Maybe I can show from my GitHub. I actually wrote to my tricks list. This is some known, like most of the Manhattan. You know Manhattan distance?
Yes.
Like if there is a 2 points, x1 and y1. Another point is x2 and y2. Manhattan distance of them is this one, absolute value, y1 or x2 plus, and the same as, why it's not drawing? Yeah, coordinate plane. There is a trick like this. Here, you can rotate your board in 45 degree in such way distance between them Now not summation, now it's maximization. It's like this. Let me write new one. Now you will rotate your, for each x, y points, you will rotate by 45 degree, such that it will turn to what? X plus y, y minus x. If you do this to this one, it will be rotated 45 degree. After doing this, let's call this one as a x prime, y prime, okay? New change it in new coordinate system. Now distance between them equal to what? Maximum of x1 prime.
What to do?
I change it the coordinate system by 45 degree.
45.
Yeah, if it's like this, listen. Now it's change it to the normal circle like this. 45 degree. So like you will do for each xy this thing, and after this you will get new coordinate system. Yeah. Now between two pairs Manhattan distance equal to what? Let's close it actually. Just a minute. Absolute value, close it. There is no plus now. This is a really cool trick. You can use a lot of the, how to say, I can do the, how to say,
Like
proof, but it will just, you need to analyze 4 cases. Like basically you are minusing from like x plus y, so you are minusing x plus y minus, let's say, x2, y2. So basically it's so x, in case of this is bigger than this is bigger than this is the direct answer. So you are, this formula rotation will calculate all 4 conditions and it will give you the, so there is a proof you can do yourself. So it's like this. Okay. I think there is a, even you have book, some Finnish guide. Did you have that book? Can you just give me that book? I can show. The PLLK wrote. Yeah, competition. Yeah, until something. This one, yeah? Actually, there is some part which is distances. Maybe I can look from there. Distance functions. Manhattan distance. So Euclidean.
Yeah.
This is Manhattan. Manhattan is Euclidean going direct like this. Manhattan is like difference of length plus difference of width, so it's like this. So basically this. Euclidean is like when you give like this sound of radius like this. Okay, and Manhattan is something like this square. Like if you say that look at the distance smaller than 3 for this Manhattan distance, it will be like this, like 3, so it's like circle like this, kind of circles. But it's not rotated. Now with that formula, rotating coordinates, now there is a proof you can even look at this after me.
Yeah, they're working.
Here it is. After rotating, now distance will be this one, not plus. This one equal to maximum. So we can just look at the maximum. This is used really a lot of Manhattan problems. If you just see Manhattan distance, just look at this.
After rotating by 45 degrees, the distance between them
This one.
This one.
Yeah.
This last coordinates here.
Yeah, just change it.
It's not
To
new.
change like this form. xy now becomes x plus y minus x.
Okay.
New coordinate system. You can look after me the proof if you want. Now what it will help? What it will help? As I said, when you say that for this point xy, give me the, let's say, distances, Manhattan distance smaller than t, okay?
Yeah.
Like t means, let's say, d. Then like here is the d distance, okay? D distance, d distance, d distance, but it's not d distance, it's just 2d distance.
Yeah.
So as like the possible pairs in this square. Yeah?
Yeah.
This is some kind of Manhattan distance trick, let's say like this. Why I need this? In my previous formula, where is that my previous formula? My previous formula actually gone somewhere. Let's open from the code. Here, previous formula. This is brute force solution. Yeah? Here is the, you find the minimum of this one, and kind of similar to Manhattan distance, yeah? Yeah? Now what I will do, at the beginning, to eliminate this part, I will, like, let's say, there is no, go to the next page, yeah? It's sad. Let's say like this. As I said, let's write one more time, it will be much easier. dj, and plus, first condition is that xj minus xi. Yeah. So for this, when you binary search the d, I will directly remove all possible pairs of ij, such that I is smaller than j, such that this is smaller than d. This is good pairs, so you don't care about, just continue.
Okay.
Okay, we looking for bad pairs, bad is the distance is in that position. Now we interested in this. We are interested in to find some, let's say, AB vertices such that xi plus xj minus xp plus c smaller than what? D. We want to find such a AB. After finding such AB, for all possible bad pairs of ij, it should be, actually, this is constant, so just put like this. This should be satisfied. Okay. Now what I will do for each possible like bad pairs of ij, I will fix that ij, and I want what I interested. I say that d minus c distance, let's say, d minus c, d minus c, and d minus c, d minus c. I said that I will create such a square for each ij bad squares. After creating that all squares, I need to find what? Such a point of the xa and xp, which is the intersection of the all squares. If there are n squares, like n square bad pairs, then I have a n square number of rectangles, not rectangle, let's say n square squares. So I want to find such a x and ab such that they are in the intersection point of all squares. How to find that? As I said, now I will do 45 rotate. For this one, what will happen? It will happen like this. Okay. And even you will transform this too. So because we now want to find a new coordinate system, yeah, this xa and xp. So it will be what? xa plus xp minus xa. Now all of them, this one also transform it, and also for each pairs, this one also transform it. Now,
Their absolute value or just
no, just a minute. Why I need absolute value? Like I said that.
because okay.
Like
I consider XP is bigger.
When is
How to find this rectangle, you mean, yeah? How to
No,
find this
point.
square? Okay.
Point is and position of 0.
Yeah, zero based. It doesn't matter.
Ah.
Now, how to find the squares?
Sistemalardan tamamlarından bulmak.
Да.
How to find the borders of this border and let's say this border of this? Basically, what I said. Now, distance of them is equal to maximum of
What do you find?
like for some ij, find it's like this square, which is the all points inside is smaller than DC distance, Manhattan distance.
Oh, okay.
Okay.
If this kind of planes doesn't intersect, we increase them.
No. First, let's try to find the squares. After this,
Okay.
like now these fix it.
Yeah.
If they are not fixed, like if it's not intersecting, by logical you will increase your binary search bigger, so your squares will get bigger.
Okay.
So for current, your fixed like transform this, and this will transform what? Just new coordinate system. For this coordinate, you want to find all new coordinate system which is like this. This both of them smaller than d minus c. Yeah? And it means that like for current point, for some point like transformed point, I want all points inside smaller than d minus c. So it means basically I will just need to go d minus c. Yeah. So if you take any point inside this, it will be maximum of the difference for this center is smaller than dc. But if you take anything outside, it will automatically, for example, this part is bigger, so it's not okay. So you will have now normal squares. If you have some n squares, can you find the intersection square?
For n?
Like if you have n squares, rectangles, let's say, if they are mixing. If there is n square rectangles, can you find their intersecting, like?
Yeah.
This is a rectangle which is intersecting all rectangles. So I want to find this small rectangle. Can you do so?
Maybe the smallest this coordinate to the smallest
Exactly.
coordinate.
Just find the maximum x, minimum x, minimum maximum y, minimum y. That's all.
And then
This will be come. Now you have some rectangle come. You want to find such a, as I said, x and xp, which is constraints inside this, but it should be new coordinates. So you can, at the beginning, you can do just take all n squares new coordinate system. So when you finally get this square, you will just try all of them and just say, is it inside or not? If it's inside, this is a possible building bridge. So that is the directly return one. I can pass code, maybe you'll understand much better if you want. Yeah, it's some kind of, but you cannot optimize this like Manhattan trick. You cannot optimize this. You should try to all possible pairs. You need different idea to optimize to the n log n multiply log n. I think even I don't know. I'm just thinking now. If I explain now, are you going to understand now? I'm just curious. Maybe I can explain. You will watch OBS one more time and try to understand. Okay. This is first idea. Basically, you are just binary searching after getting the partial sum. This is my just for all possible pairs. If, as I said, is it good pair? Just continue. This is already smaller. Okay. For others, I just look the value. Value is kind of because this for fixed ij, this is fixed, this is constant, this is constant. All of them is constant. So I just interested in that, as I said, for coordinates, making minimum and find that, what is that, this border, okay? And I also, now I just look all pairs of AB, a new coordinate system, is it inside of that found last square? If it's so, just return 1. Otherwise, return 0. And also, if this is like bad case, just this is not rectangle, yeah. This will give you 71. Now I want to explain next idea, which is not related with this idea. Let's start. I hope you will try to understand. Actually, it's not tough idea. It's again same formula, but analyzing four conditions. Four conditions mean what? Let's start. That's my building pair of the, how to say, A and B vertices that I will beat bridges between them, and IJ is all possible pairs. Now what will happen? First, like again, just we consider that I just eliminated all good pairs such that distance is directly smaller. This one I just eliminated. Okay, like pairs which is not using the bridge. Okay, and just this is not using the bridge.
It's like
For some binary things.
They are intersect already.
No, I don't care about, because I don't need to consider the square of this one. I'm just saying that this is already not without using the, how to say, bridge. It's already smaller than my binary searching key.
Okay.
You don't need to build bridge or let's say edge to make happy them.
Okay.
Happy means smaller than k the distance. So again, I will eliminate good pairs. Now I have a bad pairs. So bad pairs is have a four conditions. Yeah. First condition is that and b is smaller than g. In that case, what will be distance?
A smaller than what?
I.
I?
Yeah. AB is built bridge, edge. IJ are also all possible pairs. So for some fixed AB, I am saying that if it's like this, what will be this distance? That it will use the, how to say, bridge. And I'm again binary searching the diameter. Like it's not really different, but check function is really different. So for distance with this one, what will happen? Distance will be just, because now I'm just get reading of that absolute values. I'm just analyzing the cases.
It's IA plus it's J. Plus
DI, DJ. DI, DJ, I forgot them. It's just extra connecting. If there is a one, I just need to take them. If there is, it's just automatically 0. And it should be smaller than what? I said D, big D, diameter. And just C is also constant, so just minus. Now let me just group and write in good form, just pass here. Okay. And let's make it also here. Let's consider directly the.
Why xi minus gi?
This is constant, huh? What?
Xi minus gi.
I just put. Sorry. Yeah. And minus t should be smaller or equal to what? I just press this one. XA minus XB.
Yes.
There are four conditions, like this is going like this. First condition is this one. Second condition is B bigger than J. A bigger than I, B bigger than smaller than I, A bigger than I, B bigger than J. For all these four formulas will create me something. What? It will create me such a formulas, okay, which is okay.
Can you explain what's A, B, I, J?
A, B это вершины, которые мы выбрали, между ними, которые мы делаем C вершину длиной C. То есть, типа между ними мы сделаем ребро с длиной C.
А I, J?
А J мы перебираем, типа.
And we want to ensure that all distances smaller or equal to D.
Мы типа бинарим на диаметр, чтобы длина, вот все эти длины были между меньше или равно D. Мы бинарим D.
Now, like, why like after doing this, I will get the formulas of this formula. Like, this is like in this first formula, what we get. This is the some value. Okay, let's say the A1.
A1.
And I will get one more formula, which is from here, something like here or here, which is give me the A2 for fixed IJ. It will give me, because there is an analyze you can just do yourself, it will not make just four formulas again do same things. For xi plus xp, you will get b2 and b1. Okay. Now there is also another thing I have to mention, that what happens if it's not like this? It's like this. So is it again it will work? Yes, because like in this condition, okay, in case of like b bigger than j, but I took the formula of this one, what will happen? Xj minus xp will be negative, yeah? In case of it's not like second form. In that case of the first form, it will be negative, but plusing of the negative values will again smaller than d, so it will not affect me. So basically, I have to take just four of the conditions to cover. So just take all of them at the beginning. So you will get this for each selected ij, okay? For each selected ij, you will create four numbers like this. I can show even now that formulas one by one, but you can do your math. I just showed how to do the first one. Just go on like this for all of them. You will how to say, output that all four formulas, and you will get these four numbers. For fixed ij, you will get this. Now your task to find the xa and xp, as I said, as a like same in first solution, such that their minus is bigger or equal to maximum of all ij pairs. Let's see, is there any? Actually, I think there is a. Where is our first formula? It's like this, yeah? Actually, it's like this. xi plus dy plus d.
dj minus xj.
Actually, I prefer to, I just, like, let's put all of them this side to get this form. I just want all of them in this form, like x something minus d something, okay? Not like this. So just put all of them this part. What will you get? Here again, good. Now xj minus dj, yeah? And this is just minus, so xi minus xa, and this is just pass. Just a minute, sorry. I was doing this di, and here let's say plus dj plus should be smaller than xp minus xa, yeah? Okay, this formula is one of these four. As I said, I will do for all, like for good pairs continue directly, for bad pairs, for each formula you will find some kind of endpoint, and you are just in the end again checking all possible of xa, xp, such that it's inside that. Okay, you just for each ij you'll create some square, like again kind of not square, a1 a2 b1 b2 maybe square. You create something, you said that give me x and xa and xp such that it's inside of this one. The plus is like plus is between a1 and a2, minus is there between b1 and b2. So for each ij you will create the squares and just find the intersection of them, which is the just again minimum maximum, and for that found small that you just search for ij such that actually Manhattan probe distance also go to the same direction now. It's also creating the squares, but it's much like how to say much different tactic here. Let me stop here. You will